All right, looks like we have a few more folks joining in here with us for this session. Thank you all for being here. I'd like to introduce your next speaker. Clint is a zero trust advocate and developer with NetFoundry. And Clint, whenever you're ready, you can go ahead and begin your presentation.
Well, thank you, Molly, and thank you to DeveloperWeek for having me yet again. I was so fortunate to be able to speak at DeveloperWeek in the United States, and now I'm here speaking to our fellow compatriots across the seas in Europe and wherever else you might actually be. I'm Clint. I work for a company that's called NetFoundry. I work on this project that's called OpenZiti. It is a free open source project that you can go out and check out on GitHub right now. And it's about bringing zero trust networking into your applications. And so that's where we come from today. We're going to be talking about monitoring anything, anywhere. We're going to be using Prometheus to do that. And so we'll take a look at what that means. So we're going to find out just what is Prometheus. Hopefully it's not too much of a review for those of you who know what Prometheus is. And hopefully some of you will learn something about what Prometheus is and why it's kind of neat. We'll go through an overview of some zero trust concepts, particularly around OpenZiti. We'll add OpenZiti to Prometheus and see what that means. And then we'll see Prometheus in action. And I forgot to mention this little guy in the corner. He's Ziggy. He's our mascot because every open source project worth its salt needs a mascot, right? So you'll see Ziggy throughout the presentation. And then we'll see Prometheus, as I call it, in action. So what we've done is we've added SDKs into Prometheus, and we'll take a look at that. So exactly what is Prometheus? I'm going to be really high level. I've only got 25 minutes, so it's going to be not the deepest of dives, but Prometheus is an alerting and monitoring type of system. So when you want to collect metrics, Prometheus is one of those servers that you think about. And why would it be that we want to integrate with Prometheus, or why would somebody want to choose Prometheus as the metrics collection engine or collection server? Well, it's open source and it's free. Well, actually, if I were to put that into terms that my chief revenue officer would understand, the total cost of ownership of Prometheus is pretty advantageous because it's pretty difficult to beat free. Prometheus also is well known for monitoring everything and anything. Lots and lots of exporters. So you see it at the link at the bottom here. You can go out to their documentation page and you can go to the exporters link and you can check out just exactly what Prometheus allows you to monitor. So here's a few snippets that I just decided to choose from. Look at the databases that are supported by Prometheus. I mean, there's probably just 40 right there. Look at the hardware that Prometheus supports. There's a bunch more. Look at the messaging systems that Prometheus supports. Look at the HTTP servers the list goes, literally, if you go there and you look at the exporters, it goes on and on and on and on. And then there are also just whole other platforms and solutions that provide Prometheus metrics out of the box because it's such a popular project. It's not just popular with operators, but also developers. So we've got all these SDKs that Prometheus provides. If you're a Go developer, Ziti also loves Go, or Ziggy loves Go, but also just Prometheus loves Go. They've got Node, they've got C#. If you're like Ziggy and you love Python, you've got a Python SDK. If you love Java, like Ziggy, he likes all the languages, right? So it's wildly popular. And one of the big reasons that it became wildly popular is because it's under this umbrella of the Cloud Native Computing Foundation, CNCF, which you've maybe heard of, but if you haven't, you should also check them out. It's all about open source stuff that you can go take and run. Really neat organization. They have a big Slack you can check out and listen to as well. But there's another really wildly popular Cloud Native Computing Foundation project, which you may have heard of before, and it's called Kubernetes. We're not going to really get into Kubernetes today either because, again, 25 minutes, but Kubernetes, suffice to say, is a container orchestration engine. Its job in life is spooling up and tearing down containers on your behalf. They call them pods. Hopefully you've got a little bit of familiarity with Kubernetes because Prometheus, Kubernetes kind of go hand in hand oftentimes. So I'll be actually doing the demo later with Kubernetes. The documentation for Prometheus is really excellent. Like as I was doing my journey on Prometheus, the doc out there is really clear, really easy to understand. Not a lot of fluff, not highly complex architectures that you need to understand for the most part. Very clear, easy to understand. So it's got a lot going for it. So if, can't beat free, monitors everything, wildly popular, and great doc. It's a winning combination. When I think of a metrics collector, this is usually what comes to my mind is I will have my services running in the cloud, running in my private data center, running on my laptop, wherever they might be. And in that program that I'm writing, I'm collecting my metrics, ideally using an SDK. And then that SDK knows how to push those metrics to some big collection server in the sky. And usually we do that because these metrics, they can tend to take a lot of space. They can take processing power to process those metrics, to make pretty graphs, to do the searches, etc. This is what I thought about when I started my Prometheus journey, but it's really not what Prometheus is all about. Prometheus really wants to go out and it wants to collect the metrics from these scrape endpoints or targets. So Prometheus actually wants to do a pull-based kind of approach as opposed to a push-based approach. And that was new to me. I did not expect that. So if you haven't seen The Far Side by Gary Larson, wonderful, wonderful comic. And this is one of my favorite scenes that he created. And it just fits so well because I wanted to illustrate what the problem is with the pull-based model. Well, the problem with the pull-based model, as you probably already have figured out, is if you have a firewall in front of these services, well, then you have absolutely no access to get at your Prometheus endpoints. So what you're going to need to do is you will need to provide 3 individual holes into your firewall, exposing your 3 services just to collect metrics, which seems a little weird. And I thought it was weird because if I wanted to be able to access my metrics from my Prometheus server, I'm going to have to be able to get metrics into Prometheus. How am I going to do that? I'm going to leave off for a moment the fact that there is a node, a push gateway from Prometheus. So those out there going, there's a push gateway. It's still the same problem. You're still going to have to scrape from that push gateway. But even if you had that push gateway, generally speaking, what happens is you'll put your Prometheus server inside your private network space where it can scrape your services. And then you'll only open one port for Prometheus to do this thing they call federation, where you're able to actually have one Prometheus talk to another Prometheus and pull the metrics out of that federated Prometheus model. So here I'm showing the same thing. We have a private network, we have a firewall, we have an open hole in that firewall. Open ports are incredibly important. Open ports are attack vectors, right? They don't always seem like they could be. Even the most innocuous of things can be an attack vector, like a login page. If you made the mistake of running Java with log4j and you made a login page that logged the user that just logged in, you might want to think about upgrading or closing your port, right? So we'll maybe see how we can close our ports later too. So let's now focus a little bit on a Kubernetes network, right? So Kubernetes is known for scaling up and scaling down. Usually you deploy one cluster, maybe you deploy a few clusters, depends on how complicated you are with Kubernetes. I am a novice myself. I've not been a Kubernetes operator for a very long time, but this is a pretty typical kind of idea that you'll see. You'll have the team that writes the Go-based services, and you'll have the team that writes the Java-based services, and the Go-based team will have access to the Go-based namespace inside the Kubernetes network. The Java team will have access to the Java stuff that the Java team is supposed to be able to access. They'll both deploy their own Prometheus servers. And you do that because then in the outside of that network, you can provide a Prometheus server that scrapes basically we're federating on federating here, right? So basically you can keep scraping all the way down until you get to a level that works for you. But do notice there's still that one open port, or now in Kubernetes world that's provided by some sort of ingress container or ingress controller. But there is still going to be an open port. If you want to be able to get into that Kubernetes world, you're going to need that open port. And this is where we're going to start talking about OpenZiti now. We've laid the groundwork. We saw a little bit about what Prometheus is, why you want to use Prometheus. Now we're going to talk a little bit about OpenZiti and why you might want OpenZiti. Like I said before, it's a fully zero trust overlay network, but it's not just for your devices. It actually brings zero trust into your applications themselves. And tomorrow's keynote with Dave Hart, maybe you'll attend that and learn a little bit more about application embedded zero trust. So what is an overlay network? Well, an overlay network, we're going to start with the concept of the internet. Everybody's familiar with the internet, and we're just going to pretend that the internet is our overlay network, because that is exactly what happens with a OpenZiti zero trust overlay network. The internet becomes your network, your overlay. It's called an overlay because it sits on top of some underlay. Underlay network would be IP addresses and ports. Overlay is this abstraction on top of that. I don't want to call it physical, but that layer 3 type stuff of the OSI model, right? So we have our overlay network. We're going to start with the controller. The controller is the root of trust for a ZD overlay network. You can read about roots of trust. We have a good blog post about that. It's actually 5 parts and very detailed. You can learn all about how do you bootstrap trust. But that controller is going to do things like create identities, strong identities, very key tenet of zero trust, strong identities, authorize before connect. It'll also let you define these things called routers. So routers do just what they sound like. They take traffic and they know how to move the traffic. There are 2 basic kinds of routers. You have the routers in the middle here. They're called, I call them just routers, but you could call them a fabric router, you could call them a transit router, you can call them whatever you like. But the most important part from a ZD perspective are those things that we call edge routers, because an edge router supports what we call the edge. So far, we haven't seen anything that uses an edge router. So what is an edge? We'll get into that in a second. But these edge routers, they actually create a fully mesh overlay network. So if you configure it in such a way, you can say every router is a link listener. And if it's a link listener, then every other router that comes into the mesh will try to link to that link listener. So if you create a bunch of link listeners, you can create a fully mesh network. That fully mesh network also very, very secure. So I've added padlocks everywhere because padlocks, the universal symbol for secure and locked, right? This is a totally mutual TLS connection. This is where trust comes in that I was talking about before. That trust is established using strong identities. Those strong identities, X509 certificates. Those X509 certificates established a mutual TLS. So the edge routers connecting to other edge routers, they have to provide certificates so that the edge router that is being connected to can verify the authenticity of the person or the edge router connecting to it, and vice versa. But now let's talk about that Edge SDK. I'm going to get rid of all the padlocks because it just makes my diagram cluttered. So this is really the meat and the potatoes. This is how the do anything anywhere actually works, the universal connectivity. Yeah, you take that ZD SDK, because ZD also provides some SDKs, you put it into a device or into an application that runs on a device, and all of a sudden you have a secure end-to-end encrypted overlay network that you can also put into your applications as a developer. And that's all for one particular purpose, which is to send bytes securely across the internet from anywhere to anywhere. Now, I didn't show any firewalls. I actually could have probably shown some firewalls in between the devices and their edge routers, but there are clearly edge firewalls involved, and there are no inbound ports. And that's what we're going to do with Prometheus. We're going to take a ZD SDK, we're going to bake it into that Prometheus server, and then we're going to deploy that Prometheus server, and we're going to call it Prometheus, because at OpenZiti, what we do is we take everything that has an S and we change it to a Z, and that makes it ZD, right? Prometheus. So this is what we're going to end up doing. Well, this is what I actually did. Now a little bit more about a zero trust network. Here's a few overviews of how I think of a zero trust network in escalating terms of zero trustiness, we'll say. I'm really trying to get down to this bottom one, because this bottom one is, from my perspective as a developer, this is the end all be all. If I could have an SDK that goes into my app on one side, and you see I see device host and server host, and it goes into an app on the other side, then I have zero trust all the way between one app on the left to the one app on the right. And so that's what we're going to talk about. Zero trust networking access, this is where you normally would start, right? So going back to Kubernetes, going back to the internet and zero trust, when you put a device, or let's say a pod, into your Kubernetes cluster that provides ingress, you can create a zero trust network between two different Kubernetes clusters by just adding a piece of Ziti into the cluster, and now all of a sudden you'll be able to create zero trust connectivity between two clusters. But you're still going to have local network traffic that's being traversed. The pods will all be accessible. All the pods will be accessible to whatever namespace you deploy your Ziti host into. So you still have some trust, right? You've done a good job. You've eliminated all the open ports. There is no ingress controller in this setup. You are just using a Ziti host inside of your Kubernetes cluster. But we could do a little bit better. We could actually take and drop a pod into your, a container into your pod and provide a sidecar type of a deployment. So now you only have to traverse the pod network, right? Hey, that's pretty good. Now I'm even better. I have been able to eliminate how much trust there is in my Kubernetes network to just the pod itself. That's pretty awesome. But we can actually go one step further and get that zero trust all the way down into the application itself. Now I'm not even trusting the pod's network. I'm not even trusting the containers in the pod, right? Generally speaking, that is not how Kubernetes is set up to share that sort of stuff. But with an OpenZiti network, if you embed OpenZiti into your workload, into your application, into your container in that pod, well, then you need to be on the OpenZiti overlay network in order to communicate intra-container, intra-pod, intra-Kubernetes. Pretty neat stuff. All right. So let's learn a little bit more about application embedded zero trust. Just like Prometheus, OpenZiti is all about SDKs. We have a C SDK, we have a C# SDK, Java, Go, Swift, Android, Node.js, Python's really close. But it's all in the same idea, right? We're trying to enable developers to go out and be able to take that zero trust goodness and stuff it into your application itself. Don't leave security at your network. Don't leave security at your device. Bring it all the way into your applications themselves. I have if you wanted to go look at the presentation I did at DeveloperWeek United States, I think it's worthwhile because you'll get to learn about a lot of the superpowers that OpenZiti will provide your application. So basically, we're going to take that Ziti SDK, we're going to jam it into our container, and we're going to make a Ziti plus Prometheus application. Why would we want to do that? This is one of my favorite slides. Here I have an attacker on the left and I have a not attacked machine on the right. And we have our OpenZiti overlay network represented by that synthetic pipe in the middle of that blue line. On the left, there are three applications which have had OpenZiti added into them. We have an SCP app, a SQL app, and an FTP app. It doesn't really matter what the applications are. It's just they're different protocols, right? So SCP tries to talk to the SCP server, no problem, things work great. SQL SQL tries to talk to SQL. This is how life is supposed to be. FTP talks to FTP, things are going well. But this is a compromised laptop. That application up there has access to SCP, FTP, and SQL. But what if this hacker doesn't know that there are these other applications on the machine, and they try to use that SCP application to talk to, say, the FTP server, because FTP, insecure traffic, right? Well, with the SCP, if they tried to use SCP in that application itself, or any application, really, it doesn't matter, curl, you just imagine whatever the application might be. If they're trying to use a application which is not purpose built for that service, then it literally cannot address the service. And so if you try to have SQL Server send traffic to FTP, it doesn't work, or SQL Server send traffic to SCP, it doesn't work. This is a crazy powerful benefit because now, even if your laptop gets compromised, you can't use one application on that machine to compromise another. So a good example would be, say, a web service. If you had a web service, curl is on every machine, right? If that web service was hidden behind an OpenZiti overlay network, you wouldn't be able to use curl to access your HTTP server, and that's pretty powerful. Okay, well, I blasted through those slides a lot faster than I expected to. I don't know if there's any questions yet, but this is the time where I'm going to actually show this in action. So hopefully, I had to set it all up, and the reason I can go into why I had to set it all up ahead of time. But I've got my terminal window here. I now need to find this. So I do have a blog, three sets of blog posts where I talk about the act of why we want to do this for Prometheus, what it took to actually make it happen, and how to do it on a Ziti overlay network. And then there's the final episode, the big payoff. And so this is actually, I think it's the next slide. Why is my demo? Is it? Hey, my demo slide's out of order. This is what we're going to do. So this is what I did actually. So you have a Kubernetes cluster on the left, you have a Kubernetes cluster on the right, and on the bottom there, you see this remote machine where all this fuchsia lines go into the Prometheus servers. On the left, you see Kubernetes. The API is exposed. On the right, the Kubernetes API is exposed. There are two Kubernetes ingress controllers deployed into each container cluster. Little exclamation point shows you where there are open ports. So generally speaking, your Kubernetes API must be on the open internet. Well, it doesn't must, you can put it behind a bastion, right? But oftentimes it's just public on the internet because you need to get at it. Hopefully you secure it, but almost certainly plenty of people don't. Ingress controllers provide you ingress into the cluster. So on the left, you can see we've deployed a workload. It's called ReflectZ. ReflectZ is also a program which, written in Go, you can go out to the OpenZiti SDK, Golang SDK example, and find the Reflect server. And if you're interested in running this exact demo, I'll show you where the ReflectZ code is because it's not merged back yet. But we have a Go server on both sides. That server does nothing but listen for connections and reply back. Then we have Prometheus up there on both sides. And what Prometheus is doing is it's scraping that Go workload and providing the statistics for how many times it's been connected to, right? Very simple demo. What we'll end up doing is this. It looks a little more complicated because there's more stuff on it, more Ziti icons, but it's just to show you where the Ziti icons are. On the left is a non-Zitified Prometheus, non-listening Zitified Prometheus. So you can see there are red lines indicating where the private Kubernetes traffic is, but you can see it immediately. There are no open ports anywhere. So that remote machine that's going to be my local developer machine right here is going to make these requests. It's going to go over the Ziti overlay network. It'll enter the Kubernetes cluster A on the left, and then from there it'll offload from the trusted overlay onto the private Kubernetes space. This is because we recognize almost nobody's going to go out and app embed zero trust immediately. So you start with these things that we call tunnelers, or in this case of Kubernetes, Ziti host. And those among you who are astute will probably say, hey, that's your ingress controller. And it kind of is your ingress controller. So if I come over here and I do a reverse search for netcat to qb.reflect.service.ziti. Now I want you to pay attention to this because .ziti is not a valid top-level domain. But if I say hi there, or hi, you can see I get a response that says, you sent me hi. Hi too. It'll say you sent me hi too. Great. So I have now, this is going to cube B, which is Kubernetes B over here. I have now sent a request from my machine across the Ziti overlay into this container, into this ReflectZ pod itself, and returned data all back with no listening ports. I can do that again on Kubernetes A because I've deployed the exact same workloads in both places. Cube A, and it says it sent me Cube A, so that's cool. We're seeing app embedded zero trust in action right there. We can also come back to Prometheus. Notice that I'm going to cube.b.prometheus.svc, also not a top level domain. And that's because I'm running these things we call tunnelers. So you can see I have a Windows tunneler here. But you can see this this Prometheus server is able to monitor the Cube A ReflectZ as well as the Cube B ReflectZ. And if you look at the endpoint that it's going to cube.a.reflect.scrape.service. This is the name of the OpenZiti service, and this is the name of the identity of the service that is allowed to bind that service. So if I now go to graph and I type reflect total connections and I execute that, no, demo gods, not now. All right, let's go to Cube A and try it. All right, so there you go. Now I don't know what's going on with Cube A or B, but there we go. All right, this is what I wanted to see. So you can see before I had 14 total blue connections. Now I have 15 total blue connections, and blue is Cube B, and white or yellow is Cube A. So let's go ahead and make a few more Cube A connections. I just have to make the connection and come back and execute our query and wait. It's 5 minutes. Let's go back to 1 minute. Oh, it's 5 seconds scrape time. All right, it'll get there. I know it will. Come on, you can do it. Come on, demo. Anyway, you get the point. It'll pop up here. I'm sure it will. Why is it not working? 19. Let's go back and run the cube A. Okay, that worked. Run this again. Doesn't want to scrape. Let's check our target. Is it actually scraping? When's the last time it scraped? 1.23 seconds ago. So it thinks it's scraping it. Well, that's a live demo for you. I promise that. Hey, all right, there we go. Look, I pulled it out of the right at the end. We pulled it out. We did it. There's what I expected to see. Excellent. I'm at 25 minutes. Oh, actually, I'm not. I'm not done yet. I need to go back and I need to do this. You're thinking to yourself, how do you get OpenZiti? Well, you can go and install this via Helm. There's a Helm chart to install. Here's all of our socials. We got Twitter. We got Ziggy on Twitter. We got YouTube TV happens on Fridays. Ziti TV happens on Fridays. We got a discourse group. Join the discourse group. But the number one thing, if I could ask for your attention, GitHub, if you could get a star, just give me a star, please. This is like the like and subscribe port of this show. If you get a star, then Ziggy, he dabs. So every time I get a star, Ziggy gives me a dab. Go out there, find the OpenZiti/Ziti repository. If you think this is cool, secure, private, ubiquitous connectivity, cloud to cloud, monitor anything, anywhere. If you think it's neat, then give us a star. That's all I've got. I don't know if there were any questions. I know I'm at 25 minutes, so it's probably right on the end. And that's it. So thanks, everybody. Hit me up on Discourse. Hit me up, clint@openziti.org. Where's my build? There it is. Clint@openziti.org. Hit me up at the Discourse. Twitter, we monitor Twitters. Ziggy will reply to you if you follow Ziggy. Yeah, so that's it. All right. I think I can just say goodbye and leave. Is that true, Molly? I think that's what she told me. All right, everybody. Thanks. Hopefully there were some questions in the chat. Oh, yeah, check out our booth too. Don't forget our booth. All right. Ooh, this is inception time. Bye-bye. How do I do this without sharing my screen? I can turn my screen off. That's what I can do. There we go. Hey, all right. Ooh, Philip Griffiths is in the house. Oh, there is a commercial version. Certainly. Yeah, I didn't even mention. You can totally software or network as a service. Netfoundry.io. Thank you, Philip. Come by the booth. I'll go back to the booth and we can answer more questions there.